on the computer. All right, we should be live on YouTube. We should. Should. One can hope. Let me load up the chat on my phone so I cannot have it cluttering our beautiful screen while we educate ourselves here. Let's see. Do I have anything on my channel? No. Okay. All right. So if we are live right now, that's awesome. But I genuinely don't see anything on my phone like I typically do. Because that's awesome. Yeah, no. YouTube, I don't want to secretly load up chat on my phone. Thank you. This is epic. So YouTube tells me I'm live, but from everything I can find out on my channel, I'm not live. At least on my phone. Let me just see if I reopen the app. Does that magically make something happen? No, it doesn't. Sick. All right, let me pull chat over here. So if I could get a yay or nay on chat, let me pull a pop-out window over here. Bring it over. Okay, so I am live. Awesome. Thank you, Ghost Ranger. Thank you. Because apparently YouTube does not think it's worth telling me that I'm live. Nothing better. Am I right or am I right? All right, and I'm also going to zoom in on the page here, make this text pretty damn big. So it's big, because that's a sentence that definitely needed to be said and makes sense. Yeah. Anywho's, how's it going, boys? Hope you're all doing good. So I've got the Rust book loaded up here. Upon hearing quite a few people tell me that we should not watch YouTube tutorials, that is not advisable and not the way to go, I decided, you know what, for once, just once, just this once, I will listen to the smart, intelligent people I have in my community. Typically, I'm too stupid to listen to good advice, but just this once, I'll take the advice. So we're going to go through the Rust programming language book together. We're going to talk, have a good time, and yeah, just all around, have a good time. So thank all of you guys for being here for the live stream. I am sorry about the confusion and absolute shit show that was yesterday's non-live stream. I just moved all my stuff back to the house, and the entire computer setup was wanting to fight with me. Also, the puppies that I was watching chewed up my earpods, so I'm having to use my over-the-ear Audio-Technica headphones, which is fine. They're really good. You tell them, buddy. Yeah, that's right. You tell them. But yeah, so it was just all around a shit show when I was trying to get it set up. I was already late because I had to get on the phone and argue with the people at the bank, because apparently when you're as poor and broke as I am, when you try and mobile deposit a check, I shit you not, this is what my bank told me, I needed to give them bank statements from another bank to prove that I had enough money so that they would deposit the check into my account. Let me make that, like, I'll repeat that again. A banking institution told me that I am so poor that for me to deposit and it's not like it's an outrageous check. It's not like it's thousands of dollars. It's literally just over $500 that I have to prove that I have money so that they'll allow me to use the money I was given, which is just awesome. It's just the level of intelligence that goes into designing that system is astounding, or the lack thereof, but whatever. So yeah, and trying to get the guy to understand just how fucking retarded that state, like what he was telling me was. I'm like, dude, genuinely, I'm dumb as shit, but I'd have to get really beyond dumb to understand that I need to prove that I have money to make money. Like, huh? Like, am I born with cash? Like, come on, dog. Yes, we are going through the book. That's what we're going to be doing here. We were going to watch some YouTube tutorials there. I found a good, or at least what I thought was a good tutorial. I watched the first episode. It seemed good. So I figured we'd do that together. But many people told me, go through the book. Just go through the book. It's how you should get started. So I think everybody's in here, or at the very least, getting ready to sit down. So if I can, just get anybody in here. If you're going to be following along with me and you would like, a couple, just a couple minutes for us to talk so that you can get all ready. If you're not already set up, please just throw it in chat real quick. If I at least get one person saying, hey, I'm getting set up, please wait on me. I'll spend the next couple of minutes talking. If not, if I don't say anything here in the next minute, we'll just move on and go into reading the book and moving on with it. Getting the stream on the way, because Lord knows we're only 24 hours behind. Yeehaw. Yeah, dude. Well, the good thing is if there's anything this stream can provide you, if you've wanted to read the Rust book, but there's not an audio book version of it, here it is. Because I will just be reading out the book and maybe, branching off here and there. But we're about to unpack this Tai Lopez knowledge. Knowledge, boys. Sadly, I don't have my phone camera in front of me to show off the Ferraris I have in my garage. But that's all right. I'll do that on a short one of these days. And let me make something abundantly clear. If at any point, I don't care if I have 6 million followers on YouTube, if you ever see a short or a video where there's Ferraris and shit in the background, let me make something abundantly clear. They were rented for that one day, just for that one video. I'm not ever spending my money that way. Any specific requirements? What do you mean, requirements? For using Rust, yes, late at night is the best time to get rusty. I have experience with C#, C, Java, even though it's been a long time. I literally learned Java when I was 12 to 15. And that was I had a lot of shit going on in my life at that point. So there's not much about Java that I remember. And I also never made practical use of Java. But yeah, I've got experience. Python too, but I'm definitely not a Python wizard. Oddly enough, I know more about GDScript than I do Python itself. There is no watch together link. We're not doing the watch together thing. We're going to go through the book. I've been told by many people we should just go through the Rust book. No, I actually want to learn Rust. Okay, so I haven't gotten a message from anybody about hey, I'm getting set up, or wait on me, and whatever. So we're gonna get moving here in just a second. Yeah, so we're going to go through this all together. So this version of the text, let's just go ahead and get started. All right, let's not dilly-daddle any longer. Pretty confident with Bash. I'm not TFL's level of confident. Derek, or TT, how's it going, man? Welcome to the stream. There will be plenty of memes. Plenty. let's go ahead and dive into it. All right. The Rust programming language. Yeet. This version of the text assumes that you're using Rust 1.57, released something. Hold on. Let me check. What version are we running? Do as pkg_info Rust. Or is it Rust C? Rust 1.59. All right, we're newer. Yeet. We're cooler. It's still going to work. It's the same fucking text. It'll be fine. Or later. See? There you go. See the installation section of Chapter 1 to install or update Rust. Cool. The HTML format is available online and offline with the installations of Rust made with Rust Up or Rust Up docs -- book to open. This text is available in paperback or ebook format from No Starch Press. Yeet. Cool. Okay, I'm going to have to move this chat over here into the, like, kind of corner. Yeah, so we can continue on. And TFL, how's it going? Welcome to the stream, brother. All right, let's get on to the forward section of the Rust programming book. It wasn't always so clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you are writing now, Rust empowers you to reach farther, to program with confidence in a wider variety of domains than you did before. Take, for example, systems-level. Work that oh my god, this is terrible. Deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a select few who have devoted the necessary years to learning to avoid its infamous pitfalls, and even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to dip down to their low-level control can do so with Rust, without taking on the customary risk of crashes or security holes, and without having to learn the fine points of a fickle toolchain. Better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. Programmers who are already working with low-level code can use Rust to raise their ambitions. For example, introducing parallelism in Rust is relatively a low-risk operation. The compiler will catch the classical mistakes for you, and you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerabilities. But Rust isn't limited to low-level systems programming. It's expressive and ergonomic enough to make CLI apps, web servers, and many other kinds of code quite pleasant to write. You'll find simple examples of both later in the book. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. Fucking sick. This book fully embraces the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to learn, and welcome to the Rust community. What a nice little book. This edition of the book is the same as the Rust programming language available in print. Cool, sick. Welcome to the Rust programming language. As an introductory book about Rust, the Rust programming language helps you to write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict through balancing powerful technical capacity and a great developer experience. Rust gives you the option to control low-level details such as memory usage without all the hassle traditionally associated with such control. Cool. Who is Rust for? Rust is ideal for many people for a variety of reasons. Let's look at the few of the most important groups. Teams of developers. Okay. This is completely not relevant to me. But, whatever. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of systems programming knowledge. Low-level code is prone to a variety of subtle bugs, which in most cases other languages can be caught only through extensive testing and careful code review by experienced developers. In Rust, the compiler plays a gatekeeper role by refusing to compile code with these elusive bugs, including concurrency bugs. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the systems programming world. Cargo, the included dependency manager and build tool. Cargo is fucking sick, boys. Makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. Rust FMT, or format, I assume that's what it's short for, ensures a consistent coding style across developers. The Rust language server empowers integrated development environment, IDE integration for code completion and inline error messages. Noise. By using these and other tools in the Rust ecosystem, developers can be productive while writing systems level code. Students. Rust is for students and those who are interested in learning about systems concepts. Using Rust, many people have learned about topics like operating systems development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, the Rust teams want to make systems concepts more accessible to more people, especially those new to programming, and that's a really good fucking mission to have, like, really good. Like, I mean, we definitely need younger programmers knowing as much as the older ones, and capable of just as much. Companies. With hundreds of companies, large and small, use Rust in production for a variety of tasks. Those tasks include command line tools, web services, DevOps tooling, embedded services, audio and video analysis and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning, and even major parts of the Firefox web browser. Open source developers. Rust is for people who want to build the Rust programming language, community developer tools, and libraries. We'd love to have you contribute to the Rust language. People who value speed and stability. Rust is for people who crave speed and stability in a language. By speed, we mean the speed of the program that you create with Rust and the speed at which Rust lets you write them. Cool, I was thinking about the speed I was having to talk at. I thought that was it. Well, TFL, I'm glad you're ready, brother. Yes, Watcher, we did just start. We are barely into the introduction here. So you're at a perfect time to come into the stream. Perfect time. Okay, so let's continue on. The Rust compilers checks ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. By striving for zero-cost abstractions, higher-level features that compile to lower-level code as fast as code written manually, Rust endeavors to make safe code be fast as well. Cool. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed, and ergonomics. Give Rust a try and see if its choices work for you. Who this book is for. This book assumes that you've written code in another programming language, but doesn't make any assumptions about which one. We've tried to make the material broadly accessible to those who come from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to programming, you would be better served by reading a book that specifically provides an introduction to programming. This is good advice. How to use this book. In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters. And earlier chapters might not delve into details on a topic. Good Lord. Oh, excuse me, hiccuping. We typically revisit the topic in a later chapter. You'll find two types I can't speak. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you'll learn about an aspect of Rust. In project chapters, we'll build small programs together, applying what you've learned so far. Chapters 2, 12, and 20 are project chapters. The rest are concept chapters. Chapter 1 explains how to install Rust, how to write a Hello World program, how to use Cargo, Rust Package Manager, and Build Tool. Chapter 2 is a hands-on introduction to the Rust language. Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. At first, you might even want to skip Chapter 3, which covers Rust features similar to those of other programming languages, and head straight to Chapter 4 to learn about Rust's ownership system. However, if you're a particularly meticulous learner who prefers to learn every detail before moving on to the next, you might want to skip Chapter 2 and go straight to Chapter 3, returning to Chapter 2 when you'd like to work on a project applying the details you've learned. Nice. Chapter 5 discusses structs and methods, and Chapter 6 covers enums, match expressions, and the if-let control flow construct. You'll use structs and enums to make custom types in Rust. In Chapter 7, you'll learn about Rust module system and about privacy rules for organizing your code and its public application programming interface, API. Chapter 8 discusses some common collection data structures that the standard library provides, such as vectors, strings, hash maps. Hash maps, I've definitely never heard of that shit. I'm interested. I mean, obviously I've heard of vectors and strings, but hash maps? What? Interesting. Definitely want to learn more. Chapter 9 explores Rust error handling philosophy and techniques. Chapter 10 digs into generics, traits, and lifetimes, which gives you the power to define code that applies to multiple types. Chapter 11 is all about testing, which even with Rust safety guarantees is necessary to ensure your program's logic is correct. In Chapter 12, we'll build your own implementation of a subset of functionality from the grep command line tool that searches for text within files. For this, we'll use many of the concepts we discussed in previous chapters. Chapter 13 explores closures and iterators, features of Rust that come from the functional programming language. In Chapter 14, we'll examine Cargo in more depth and talk about best practices for sharing your libraries with others. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable their functionality. Okay, this is like genuinely just like what everything's going to cover. So I think we get it. Let's skip down. Finally, some appendices contain useful information about the language in a more reference-like format. Appendix A covers Rust keywords. Appendix B covers Rust operation symbols. Appendix C covers derivatable traits provided by the standard library. Appendix D covers some useful development tools, and Appendix E explains some Rust additions. There is no wrong way to read this book. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience any confusion, but do whatever works for you. An important part of the process in learning Rust is learning how to read the error message the compiler displays. These will guide you towards working with code. As such, we will provide many examples that don't compile along with an error message the compiler will show in each situation. Know that if you enter and run a random example, it may not compile. Make sure to read the surrounding text to see whether the example you're trying to run is meant to error. Ferris will also help you distinguish code that is meant to work. Okay, this code does not compile. This code panics. This code does not produce the desired behavior. Cool. All right. Source code. The source code files, yeah, can be found over there on GitHub. All right. Yes, actually, hold on. Since we're at this point in the book, I will go ahead and Control C and copy this. Oh wait, what am I doing? And I'll post it down here in chat. There we go. So this is the specific getting started page that we're on. All right. So everyone can come straight here to the page. If you don't already have it loaded up, here you go. Here's the book. You'll you'll get right up here, and you can either follow along with us or whatever. Does Rust have I have no idea. I'm sorry to hear that, Scott. Hopefully it gets forwards here real soon. All right, so let's start our Rust journey. There's a lot to learn, but every journey starts somewhere. In this chapter, we'll discuss installing Rust on Linux, Mac OS, and Windows, writing a program that prints Hello World using Cargo, all that good stuff. All right, so I'm going to skip this because I'm going to assume most of you have Rust installed on your system, which is really not too complicated. Like I'm pretty sure most of you guys can get Rust installed. The interesting thing is I'm on OpenBSD, so there's definitely no instructions here that are relevant. So yeah, but when it comes to installing Rust, let's see. The command downloads a script and starts the installation of the Rust Up tool, which installs the latest stable version of Rust. You might be prompted for your password, which, let's be honest, I hope to God you are. That's kind of important when installing programs. And you will also need a linker, which is a program that Rust uses to join its compiled outputs to one file. It is likely you already have one. If you get linker errors, you should install a C compiler, which typically includes a linker. A C compiler is also useful because some common Rust packages depend on C code and will need a C compiler. So, you know, something like GCC, Clang, you know, you get it. And I've got GCC, like, again, it's stating it here. Linux users, you should already have GCC or Clang installed. But again, if you don't have either one installed, not a big deal. Just install it. I have, as far as I know, I have both installed. I'm sure I have GCC and Clang. I'm like 99% sure I've got both. So let's move on past the installation. Let's read about writing a Hello World program. And I can go ahead and do that. So let me get this moved over here, and we will move our window up here. Why not? All right, so first thing, now that you've got Rust installed, let's write your first Rust program. It's traditional when learning a new language to write a little program that prints out the text "Hello World" to the screen. So we'll do that the same here. Perfect. Awesome. So we're going to create a project directory, and you'll start by making a directory to store your Rust code in, of course. Now, if I ls here, you might see it. I actually have Hello World already made here. So let's cd into Hello World. And I don't have anything in here. All I've done preemptively is I knew we were going to make a Hello World. Like, that's for damn sure. I mean, you got to. When you learn any programming language, you got to make a Hello World. You just got to. It's the rules of the land, okay? If you don't, you're genuinely the worst, okay? Just make a Hello World Rust program. All right, so now we're going to make a new source file and call it main.rs. So let's make it main.rs for Rust. Cool. All right, so we've vimmed into our file. We've got our exciting Hello World program. Oh, all right. So now what we're going to do is, if you're using more than one word in your file name, use an underscore to separate them. For example, use hello_world.rs rather than hello_world.rs. That's, please God, if you're a programmer, use this naming convention. Just do it, okay? I don't always follow this. Like my max vol and max down scripts don't have an underscore in between them. Like sometimes I don't use it, but like if you're gonna be making stuff that, you know, is like actually providing functionality that's like really useful and you're gonna be sharing it with the world, please God, use that naming convention. Just do it. Just do it. Okay. So now we're gonna make our main function here, and it's gonna be obviously called main, and it's only going to have one thing in it. It's just going to be a print line, exclamation point. That's how it's done here. So let's actually just write it. I'm not going to copy and paste. We're not going to be degenerates here, okay? We're going to write it because we're original. Main, and give it the brackets, and then let's see. I don't like the. I hate that's the way of doing stuff nowadays, but you know. See, I prefer. Hold on. Let me just put in the bracket and like actually explain like what's going on through my head. In C, I like to write my functions like this. Oh shit. Okay, I don't know why, but all of a sudden in Vim, like my backspace is not working for some reason. Don't know why. But I typically write my code like this. Will you let me, good Lord, just write at the beginning of the line? Thank you. I normally do it like this. Oh my God. Like that. That's normally how I would write my function. So with two brackets and then the code in between for that function on totally separate lines. But here, that's not how you do things. Okay? And it's fine. It's fine. Okay? I get it. I get it. And I know some people prefer writing code this way. It's obviously you don't have, instead of having the brackets just wasting an entire line, two of them, you just have one. I get it, but that's just how I'm used to formatting things. But it's all right. I will get used to it, and the world will appreciate me for it. Okay. Hello world. We're not going to do the comma in there because we're cooler than that, and we're going to give it an exclamation point, obviously, and give it that. Oh, well, we can just delete these two lines because we've already got that. Save our hello world, and then let's go down here. Regardless of your operating system, the string hello world should print out to the terminal. Yes, sir. Yes, sir. So let's do rust C. Oh, wait, hold on. What am I about? I was reading the Windows one, and I like didn't even catch myself for a second until I started typing it out, and then just saw Windows right there above it. I'm like, oh, wait, nope, don't need to do that. What am I doing? Like, oh, well. Yes, so I'm still going to do the same thing, but I started reading the Windows one and I freaked out for a second. I was like, oh wait, no, do not need to be following Windows advice here. So let's rust C it, so let's compile our script, and if we ls, we now have our actual binary. So if we launch that, hello world. Sweet. We have our beautiful, beautiful Rust program written, working, printing out our hello world. Anatomy of our Rust program. Let's go through this. I'm going to use camel case. If you could explain what camel case is, because I actually don't even know what camel case is. How are braces bloat? Come on, man. What does Haskell use? Like three of these characters for stuff. Like I look at Haskell code and I see so much of this shit. Like I don't know. Like Haskell. Honestly, like if we're gonna be real talk, I can look at Haskell code, and if I'm just glancing, like if my head is moving fast enough, I can see Haskell code and for a split second mistake it for brainfuck code. And that is scary. Like, let's just be honest. In case you want to loop it like I'm doing. Ah, camel. Oh, okay. Oh, okay. I did not know that's what it was called. That's like the standard naming convention for C#. I did not know that was what camel case was. Thank you guys. I had no idea that there was a term for that. You genuinely, like, a lot of my knowledge comes from like having a community around that's willing to educate my dumb ass. So let's go, boys. Let's review in detail what just happened in your Hello World program. Here's the first piece of the puzzle, the main function, of course. These lines define a function in Rust. The main function is special. It is always the first code that runs in every executable Rust program. The first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. Also note, and by the way, just again, if you're for whatever reason deciding to like watch this live stream and learn Rust, and this is your first ever programming like language at all, just know that's pretty much how almost every coding language works. If there's any parameters to pass into a function, they're inside of the parentheses with the function. Also note that the function body is also wrapped in curly brackets. Rust requires these around all function bodies. Awesome. That's also pretty much true with every programming language. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. If you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called Rust Format to format your code in a particular style. The Rust team has included this tool with a standard Rust distribution like Rust C, so it should already be installed on your computer. Check the online documentation for more details. Inside. That is lit, okay? Like the fact that you could they have a tool that you can just run and it will even if you like write in the worst formatted style, like you're just a troglodyte in the way that you write, they have a tool that'll like fix it and make it look readable for others. That is awesome. Also, kind of, maybe we should focus on teaching people how to format stuff, but I still like the feature. Kudos. Chris, how's it going? TFL. Yeah, squiggly brackets. See, there you go. That's it. Squiggly brackets. Come on now. All right. Inside the main function, we're running the following code. Yep. This line does all the work in this little program. It prints text to the screen. There are 4 important details to notice here. First, Rust style is to indent with 4 spaces, not a tab. Yeet. Second, print line calls a Rust macro. If it called a function instead, it would be entered as print line without the exclamation point. We'll discuss Rust macros in more detail in Chapter 19. For now, you just need to know that using the exclamation point means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Third, you will see in the Hello World string that we pass this string as argument to print line, and the string is printed to the screen. Fourth, we end the line with a semicolon, which indicates that the expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Wait. Hold on. Most lines of Rust code end with a... Well, oh yeah, okay. I was confused there because I was like, wait, why would a string or a command, like why would it not end with a semicolon? And I was like, oh, well, yeah, you probably might not be done with the command in one line, but that's like the expression might be longer and it's easier to format it with it just not being on one line. Like, duh. I was just so confused there for a second because I was like, wait, hold on, when are you not gonna end an expression? Like, what? All right, compiling and running are separate steps. If I could speak and read, you've just ran a newly created program, so let's examine each step in the process. Before running a new Rust program, you must compile it using the Rust compiler by entering the Rust C command and passing it the name of the source file like this. If you have a C or C++ background, you'll notice that this is similar to GCC or Clang. After compiling successfully, Rust outputs a binary executable. On Linux, macOS, PowerShell, or Windows, you can see that the executable by entering the ls command in your shell. On Linux and macOS, you'll see the two files. You'll see the two files. With PowerShell on Windows, you'll see the same three files that you would using CMD. Okay. So there's a PDB file as well. Cool. Sick. This shows the source code file with the RS extension, but the other executable file, and when using Windows, a file containing debugging information with the PDB extension. From here on, you'll run the main or main.exe file like this. Print hello. If you're more familiar with dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead of the time compiled language, meaning you compile a program to give it the executable to someone else, and they can run it without even having Rust installed. If you give somebody a .ruby, Py, or JS file, they need to have Ruby, Python, or JavaScript implementation installed. But in those languages, you only need one command to compile and run your program. Everything is just a trade-off in language design. Just compiling with Rust C is fine for simple programs, but as your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. Yeet. Let's learn about Cargo, boys. Yeah, everything can be a printed. Yeah, I'm not. There's still plenty of reasons that I'm not interested in eLisp. I think it uses the same rules as Perl for the semicolons, where it's not always needed. Not as strict as C or C++. I mean, I would assume so, but also, I don't know. It's kind of weird to make it like where like there's a few cases where it not be necessary. Wait, hold on. You guys are getting this in 144? Why? I'm streaming in 1440. Like what? Bitrate, yeah, my bitrate's fine. Yeah, it should be in. It's 1080p for you. Okay. Yeah, okay, cool. I was like, I should be streaming in high quality. Should be. Anyway, all right, so let's go with Cargo. Cargo is Rust's build system and package manager. What the genuine fuck is this? Most Rustians use... Dog. Hold up. Bruh, I really want to learn this language, like, no lie, and it seems extremely interesting, but the sad part is as much as people want this to be a meme live stream, you're gonna get it. Like, the wanting it bad was worth it. We have our first meme of the book, Rustians. Rustaceans. Fuck me if I know. All right, we have a term for crustaceans, but with Rust. Oh shit. Me too, man. Well, this stream is definitely going to be broken into multiple parts because I need to essentially go I'm gonna have to go back and walk the puppies and dogs that I was dog sitting for here in about 15-20 minutes. I'll need to head out and go over there and take care of that. And so at the very least, this is going to be broken up into a few parts, because I'll have to make it at least 2 parts, but this book is going to take us a while to get through. I mean, we're learning a programming language. There's definitely going to be plenty of these to come through. Yeah. Rust stations. Yeah, that's just it's just a crazy ass name. Like the fact that you have a term for the people who write in Rust, and it's like being an American. Like you take your country, like your, I don't even know what the term for that is. Like what you call people based off of country. Cargo is way better than Perl CPAN. I don't even know what Perl CPAN is, but I can tell you, no matter what, Cargo dicks on it. It's a fact of life, all right? Anyway, most of that term use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that you need, that your code needs, dependencies. The simplest Rust programs, like the one we've written so far, don't have any dependencies. So if we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. Good Lord, if I could read. As you write more complex Rust programs, you'll add dependencies. And if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following. So we'll do cargo --version. Yeah, there we go. Cargo 1.59 SIG. If you see the version number, you have it. If you see an error, such as command not found, look at the documentation for your method to install Cargo separately. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your project's directory or wherever you decided to store your code. Then on any operating system, run the following. All right. Eden. I like it. No. I don't trust Perl. I just don't trust Perl. Cargo new hello _ cargo. Cool. Now cd into hello cargo. All right. We've named our project. The first command creates a new directory called Hello Cargo. We've named our project Hello Cargo, and Cargo creates its files in a directory. Excuse me. And list its files. You'll see that Cargo has generated 2 files and 1 directory for us: a cargo.tml file and a source directory with a main.rs file inside. It has also initialized a new Git repository along with a .gitignore file. Git files won't be generated if you run Cargo new with an existing Git repository. You can override this behavior with cargo new --vcs equals git. Okay. Open cargo.tml in your text editor of choice. Should look similar to the code in listing 1v2. Let's do this. Oh wait, hold on. Into cargo.tml. So we've got package. Yeah. I mean, if you've ever seen like an Arch package build file or something like that, this looks pretty similar. We've got name, version, edition, dependencies down here with nothing under it. All right. Yep, we got that same look here. This file is in Tom's obvious minimal language format, which is used for Cargo's configuration format. The first line, package, is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information Cargo needs to compile your program: the name, the version, and the addition of Rust to use. We'll talk about the addition key in Appendix E. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We don't need any other crates for this project, but we will in the first project in Chapter 2. So we'll use these dependencies sections then. Now open source.main and take a look. Fin source main.rs, print line hello world. Yep, you know, it's the shit we expected. Cargo has generated the hello world program for you, just like the one we wrote. All right, so far the differences between the previous project and the project Cargo generated are that Cargo placed the code in the source directory, and we have a Cargo TML configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for the README files, license information, configuration files, and anything else not related to your code. Using Cargo helps you organize your projects. There's a place for everything, and everything is in its place. Perfect. If you started a project that doesn't use Cargo, as we did with the Hello World project, you can convert it to a project that does use Cargo, move the project code inside of the source directory, create an appropriate cargo.toml file, and move on. Cool. Sounds good. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. Build your project entering the following command. All right. Cargo build. Cool. If all goes well, should print out to the terminal. Running Cargo build for the first time. Oh wait, hold on. This command creates an executable file, blah, 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 rather than in your current directory. You can run the executable with this command: target debug hello cargo. If all goes well, should print out to the terminal. Running Cargo build for the first time also causes Cargo to create a new file at the top level, cargo.lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. We just built a project with Cargo build and ran it with this, even though we didn't run it because it's going to work. I don't need to run it. I trust that it's going to just pop out with hello world. But we can also use Cargo run to compile the code and then run the resulting executable all in one command. Ooh. Cargo run. There we go. Look at that. Built it again and ran it. We get hello world down here. Kill. Kill, kill, kill. Let me zoom in just a bit. One more. Control L. Let's see. Yes, I am a Perl hater. Totally. I will not deny that. Yes, I do like the fact that just out of the box it's integrated with Git. It's pretty nice. Jake, how's it going? Welcome. Mm-hmm. Yes, I knew Cargo was lit from the beginning, but it's really awesome. Notice that this time we didn't see output indicating that Cargo was compiling hello Cargo. Cargo figured out that the files hadn't changed, so it just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it, and you would have seen this output. So we would have had a third line. Yeet. Cargo also provides a command line called the Cargo check. This command quickly checks your code to make sure it compiles, but doesn't produce an executable. Cool. Why would you not want an executable? Often cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, using cargo check will speed up the process. As such, many Rustations run cargo check periodically as they write their program to make sure it compiles. I'm telling you, I'm not going to get used to saying that fucking word. It's genuinely not going to happen. Then run cargo build when they're ready to use the executable. Let's recap on what we've learned so far about cargo. We can build a project using cargo build. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores in the target/debug directory. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and Mac OS versus Windows. Building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. This command will create an executable in target/release instead of target/debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark with the executable in target/release. Very important and nifty. Cargo as convention. With simple projects, cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your program becomes more intricate. With complex projects composed of multiple crates, it's much easier to let cargo coordinate the build. Even though the hello_cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the build or check out the code using git, change to that project's directory, and build. So cd into here. Wait, what? In fact, work on any existing project. Oh, okay. For some reason, I was like, is these actual commands it wants me to run? I was like, these cannot be actual commands it wants to run. But no, they're examples of how simple it would be. Gotcha. Yeah, just git clone a project and cargo build it. Yeah, that's pretty lit. Summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust, update to a newer version of Rust, open locally installed documentation, write and run a Hello World program using Rust C directly, create and run a new project using the conventions of cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So in Chapter 2, we'll build a guessing game program. If you would rather start by learning how common programming concepts work in Rust, see Chapter 3 and then return to Chapter 2. I'm fine with just moving on to building a guessing game. I mean, come on. Let's be real. I don't think anyone here has a problem with just moving on and building a guessing game. Sounds good. Well, so far from what I'm reading and seeing about it, it's definitely a fucking good language. It's really nice. Python has pip, but pip is not integrated nor nearly as, like pip is pretty much just a package manager. I don't think it does any. I don't think you can do. I don't think pip does anything with building. I don't think it does. But I'm sure that there are languages that have something comparative, but I don't know that they have something that's like literally the same or does as many things as cargo does. Awesome. I'm glad to hear it. Thank you, guys. Thank you, Chris. Yeah, sure you're not TFL. I know you. Come on. I'm going too slow for you. I know for sure. Now, let me check the time. Okay, it's exactly 5 o'clock, and I kind of need to head out. So let me just go ahead. I'm going to poll everyone here. So I want to go ahead and move through chapter 2. Would everyone here prefer that we just take a 30-minute break? Well, it'll probably be more like an hour. Let's make it an hour. We take an hour break, and then we come back. We get back to the guessing game, and we keep working through the book for a good portion of this afternoon. Or would you guys like to just have me, when I get back, schedule it for tomorrow, and we all meet up tomorrow and do this for a couple to a few hours? It really depends on what you guys want. I hate to cut it off here, but I do have to go take care of those pups. Beer break. All right, I like it. Yeah, so I think make another stream as soon as you get back. All right. So I've got one vote for just. I'm up for both ways. All right. Well, then how about this? I will go ahead and before I leave, I'll quickly go ahead and schedule the next live stream. I'll whip up a thumbnail real quick for it, and we'll do the next stream when I get back. But just because I know that there's some of you guys that are like, it's close to the middle of the night, or you want to get sleep, just so those people can at least hit one cycle of REM sleep, we're going to make it an hour and a half. Okay, so I'll schedule it for 6:30. Okay, so that's little less than an hour and a half from now, but that gives the people who like need some sleep, you can at least get some REM sleep, and we'll be back. So I've got a whole bunch of people saying that tomorrow's fine. We should probably do it tomorrow. All right, you know what? I'm gonna re-poll this, okay? Just we'll do the 6:30 thing if I get enough people saying I'll be here, okay? Just throw in chat, you'll be here. If I only get like 2 people saying that they'll be here for it, we'll just schedule it for tomorrow, because I really don't want to make a whole bunch of people miss out. Oh yeah, TFL like is reading this like it's the Bible right now. He's like, oh, he's like, really? He's like, I'm a lost soul. I need to be saved. Give me more. All right, there's one. I'll be here. Okay, 7:30. Yeah, well, I mean, it's 6:30 my time. I'm Central Standard Time. All right. I think most of you guys can make it. All right. Well, we'll go ahead and end it off here then, and we'll pick it back up in our first little actual chapter of building something a little bit more than a Hello World program. So, sick. I hope all of you guys have a good one. I hope you enjoy your break, and I'm really happy to be doing this. Hopefully, I'll get to see as many of you guys as can make it. Those of you who need to get sleep, I hope you get good sleep. And if you don't make it, you don't make it. It's fine. Get your sleep. The recorded stream will obviously stay up. Okay? All right. Bye. Bye, all you fine folks. I'll see you at 6:30, or that's my time. I'll see you in an hour and a half.